Picking back up with our polar curves, we just graphed this r sine of 6 theta just a moment ago, and we saw that it's actually a 12-petaled rose. Each quadrant has 3 petals in it, so you can get some very, very interesting looking curves here. If we looked at this very last one, you could see we'd have 1 minus 2 cosine of theta. Honestly, just giving some thought here, the smallest cosine could ever become is -1. -1 times -2 is a +2. 2 plus 1 is 3. I'm just giving some thought here as to the size of the window. So I'm going to make my x mins and x maxes 3.5 and -3.5 as well to have adequate space. If you ever didn't graph that correctly, you can always fix that quickly. But here you can see an inner loop here. You can get some very, very unique kinds of shapes. Tell you what, though, what we're really going to get into, I just want to do one last problem on this video. Summarizing the link between the two systems, in the highlighted forms, so very, very, very important for us to realize that these 4 highlighted formulas are the key, or are the keys to going between the 2 different systems, to go and convert formulas in one system, like in polar, to go to rectangular, for example. So let's take a look at r equals 4 sine of theta. If that looks very familiar, you can see that we graphed that earlier. Bold claim, we're going to say that's a circle. And the real question is, can we prove that this is a circle? Now, it's very, very tempting for kids to want to square both sides here. And here's the thinking. Oh, if I could only get r squared, then I'm good to go. And I'm going to show you what happens when you do that. It's actually not what you want to do. You can happily get r squared as x squared plus y squared. That will lead you to a better form of the equation to get rectangular. The word rectangular means go back to x and y. But the problem is we've got this 16 sine squared. So as good of an idea as that might have sounded to be, it's actually not going to help us. However, that r squared is a very, very, very smart idea. The bottom line is there's another way to get an r squared rather than raising both sides to the second power. And that is, and look at this, this is the key to doing it. I'm going to multiply both sides by r. Now, at first glance, you might think, well, you're doing the same thing, but clearly we're not. I'm not raising both sides up to the second power. I will now get r squared, and then I'll have 4r sine of theta. And you might think, well, how is that any better? It's worlds better because the left side has a link right here, as does the right side. You see, sometimes you might be able to square both sides and have everything go perfectly well. But this is a completely different way to look at the problem. Here's x squared plus y squared equals, well, r sine of theta we just saw up here, that's y. So you have 4y. Now, the beauty of this new equation is that there are no more r's, there are no more thetas. The question is still, do we really have a circle? Well, we do. If I subtract a 4y from both sides, we can complete the square. Completing the square means taking half of your linear term. I'll take half of -4 to get -2. I always tell my Algebra 2 students to put a star by that term that we just took a half of because we're not done seeing it. But then you square that term, that -2, and you'd get a 4. The reason is you're going to add a 4 on this left side, you'll add a 4 on the right side. And now with this trinomial, this will factor. We have rigged the problem to factor. It's a perfect square. That's why I put that star right there. It's going to be y minus 2 quantity squared. This is a circle. It has a center at 0, 2. And our radius is going to be a2. Because again, we'll have x minus h quantity squared plus y minus k quantity squared equals r squared. Your center is always h, k. Your radius, you can see over here, r squared is 4. R would be a 2.